Maybe we could begin by just going around the table and introducing ourselves and saying something about ourselves that will help everybody else get oriented to who we are. I'm Jim Terrel.
Which way do you want to
and
go?
I'm from, I live in Rossland, and I've been involved with the Kootenay Nuclear Study Group for about 10 years. I was an intervener at the technical hearings of the uranium inquiry, and I hope to start, at least as a starting off point, to talk about where the uranium mining issue is in BC right now, and then to go from there.
I'm Michael Gilfillan, and I live in Thrums, and I'm also with the Kootenay Nuclear Study Group, and I've been with them slightly less time than Jim has, and I was involved during the hot years back in the late 70s and the early 80s. And I guess my concern is with the whole nuclear cycle, right from the taking of the uranium from the ground to the disposition of the waste at the other end. And so that's my concern.
My name is Melanie Moore. I'm from Seattle. And I've just been down at the Hanford Peace Camp for the week. I was arrested at the first action at the DOE office. And I'm part of COHA, the organizing group. I'm also part of SNAG, which is Seattle Nonviolent Action Group. And I have a real major distress over the whole process of uranium mining to what the Purity plant does.
I missed your first name, I'm sorry.
Melanie.
Melanie.
And I've been a bit involved with the BC actions through being in Victoria. A friend of mine was doing some of the sleeping, well, she put up her tent on the Parliament lawn, and I was there then. And I don't know very much about uranium mining, so I'd like to get a bunch of notes and take it back and possibly write an article for a Seattle paper that I'm involved in.
My name is Sandra Cartwright, and I'm one of the people doing the Hanford update on Thursday night. And I'm also a member of the committee that's putting on the summer school. And I know very little about uranium in BC or anywhere else, and how it works into the whole nuclear fabric, and so I'm here to find out more.
My name is Sue Anderson, and I'm involved with the BC Hanford Action Group, which is in Nelson. And I live in Blewett. I was quite distressed a year ago when the Hanford Action Group formed to find out about Hanford and how close it was and what was involved.
I'm Dan Dalgaard. I'm a science teacher at Salmo Secondary, trained in chemistry and physics, and come from a very for very personal reasons, and partly including my work with kids. It concerns the area of nuclear arms and nuclear industry in the province, and my kids do as well, students that I teach.
My name is Bill Freeman. I've had a long time interest in the whole uranium fuel cycle, from the taking of it out of the ground until the final end product, either nuclear weapons or for power reactors. So I'm also here to get the most recent information as to what's going on with respect to uranium exploration or mining in BC right now.
My name is Jack Ross. My most recent involvement with this issue was in the blockade of uranium mining in northern Saskatchewan 2 years ago, and that sort of brought to a focus a great many years of concern in the peace movement.
My name is Karen Rankin. I work as an engineer to develop radiation detectors for environmental use. And the more I learned about it, I was second hands before I took the job, and the more I learned about it, the more I quit the job. I've been concerned about handling radiation for a long time. I just like to know what kind of things we don't know.
I'm Margie Nava. my primary concern is uranium is the weapons connection. I'm also concerned about environmental and health effects. And I heard a rumor that Jim was going to say something about radon today, so that's what I'm mostly interested in.
Radon.
Oh,
They're doing a study in Castlegar, radon in the homes, and I wasn't able
Oh, yeah.
to be put on that study, and it seems to be of interest. A lot of people there.
I'm Brian Wiley, and I'm also a member of the group. Took some jam to say that. I'd like to apologize for the lateness and stuff, and our inadequate preparation, but it'll get better as the night goes on. I've been involved in uranium issue off and on, I guess, mostly off for the last number of years, but I was involved in the Beta Commission in Saskatchewan when the Saskatchewan government whitewashed Puff Lake and involved in different protests. And so it really upsets me. It doesn't matter what it's going to, although the bomb connection I suppose is the worst, but I'm really upset about any uranium getting out of the ground at any time. I just want to find out what's going on.
Well, it's interesting to hear some of you say that you'd like to find out what's going on. Personally, I would like to find out what's going on too, and that's one of the reasons that I sort of clung to this workshop, because I thought that if anybody did know about anything that was going on in BC that I hadn't heard about, that they might eventually turn up here and say something about that. Maybe I could sketch a little background for people who may not be familiar with the situation in the province as far as uranium mining is concerned. And I'll give you an idea of what I had thought about getting into a bit, but maybe there's some other direction that people would rather go. In the middle 70s, there was a boom worldwide virtually in reactor construction and in uranium mining. The price of uranium went up to close to $50 a pound. It was driven up partly by market forces and partly by a cartel of uranium producing countries to that level, and it became a very desirable and trendy kind of thing to be looking for. During that period of time, there was uranium exploration that was going on basically all over the province of BC, or what seemed like all over the province of BC. There wasn't really very much going on the coast, but there was a lot of activity going on in the Kootenays, here in the Kootenays. There was activity going on around Grand Forks, around Rock Creek, in the Kelowna area, and in up and down the whole Okanagan area, up around Kamloops and north of Kamloops. A little community called Clearwater had one of the major finds, and then there was another kind of cluster of exploratory activities going on in the far northwestern corner of the province, around a little mining town called Atlan. And that of course led to a lot of concern on the part of people in the communities. I think one of the initial groups that sounded a warning about the hazards of uranium mining was the BC Medical Association, and they took a leadership role, and a couple of doctors from the Clearwater area, in fact, sort of led the charge. There was, as far as this community is concerned, there was at one point exploration going on in the watershed from which the community of Genelle and China Creek gets its drinking water and irrigation water supply. Genelle and China Creek are a little community between Castlegar and Trail on the Columbia River. And China Creek is a creek that comes down out of the mountains and empties into the Columbia there. They discovered that there was blasting and drilling going on in their watershed, despite the fact that they had it posted for over 25 years that there should be no trespassing in the watershed, and despite the fact that in The community watershed, water supply watersheds in larger cities like Vancouver and Victoria, it's actually illegal to enter those watersheds without first having medical examination. When they confronted the Department of Mines about the problem, the Department of Mines said that it wasn't going on. It simply wasn't happening. They knew that it was because they heard the blasting, and subsequently they discovered the empty dynamite boxes, and they could see people going up there. So they established a blockade across the road, and for a time prevented the company from going into the watershed area. By and by, 3 men from the community sat down to obstruct the road and to prevent a bulldozer from going up, and were charged with obstructing a public roadway, and were subsequently tried. That was, as far as I'm aware, the only civil disobedience that occurred during the whole anti-uranium fight that went on for some years. It was particularly effective, I think, because it was a rare event. It was also particularly effective because the 3 individuals involved had never done anything like that before. They were from the community. One of them was a scout leader. One of them was a fireman at Cominco. They all worked for Cominco. They were doing it out of sheer idealism and had a very strong case simply on those grounds when it came to court. That and other events, I think, eventually persuaded the government, first of all, to put a moratorium on exploratory activity, and then to establish a commission of inquiry which would look into the potential environmental and health effects of a uranium mining industry should it occur, and to look also into the adequacy of the existing regulations to regulate such an industry. The people who were involved in the movement on the other side, many of them were very concerned that this inquiry or some official process should look at the possibility that uranium mining should never occur in the province. That since it wasn't happening now, that was fine and dandy, and it should go on being that way, and there should be some legislative statement to that effect. The commissioners on the inquiry never interpreted their mandate particularly in that way, and that led many people in the movement to see it as basically a whitewash. I am inclined to see it a little bit more generously than that. They did look at medical questions that I think they might not have looked at otherwise, because the chairman of the commission was a medical doctor and a thoracic surgeon, which predisposed him to look at lungs, which is the main organ at risk among uranium miners and people living in uranium communities. So that there was a very rigorous look at that. But about halfway, and I can go on a little bit about the inquiry, since maybe this is a bit of my hobby horse here. But I think the inquiry did serve some valuable functions. One of the functions that it served was that it provided groups that were opposing uranium exploration and mining in their communities with cash. And that's something that, as you probably know, we're always short of. So it was really, really nice to be able to hire several people full-time to work on nothing but that issue during about a 6-month period of time. The technical hearings were held in Vancouver, and that provided us with an opportunity from individuals from all of the communities around the province that had uranium exploration going on in them to send representatives and to get together and meet one another, and in fact to cross-examine all of the expert witnesses who were gathered there to provide testimony to the commissioners, and some of them were quite considerable. There were people who were worldwide experts in uranium geochemistry, for instance, which is not a subject that I would have even thought existed before that time. So it was interesting to find out about that. We were able to persuade the inquiry to have a special session that lasted for a full week on the subject of uranium exploration all by itself. And that grew almost entirely out of the issue that was precipitated in Genelle. When the 3 individuals who did the civil disobedience in Genelle got to court, the judge said that he would be willing to hear testimony about potential health effects or environmental effects of uranium exploration, but that he would not hear testimony about health or environmental effects of uranium mining, since that was not really at issue. Well, all of the evidence was about uranium mining, so that it was possible to shoehorn a little bit of expert testimony in there on the grounds that a uranium exploration site was a little bit like a uranium mining site. But beyond that, it was really very difficult because it was a subject that hadn't been looked at in a great deal of detail before. Although, as it turns out, there were some legitimate concerns. An exploration site is not going to be as severe as a mine site, but there were instances that happened subsequently of drilling muds being released into underground water supplies, into aquifers, and contaminating wells almost instantly within an hour or two of the actual drilling occurring, because the pressure was lost into the aquifer. There were evidently, it was never really clearly established, but there seemed to be instances of actual radioactive contamination of a lake in Saskatchewan that was a result of drilling near the margin of the lake. What became really clear was that it is almost impossible in reality to draw a line between exploration and mining. That's almost arbitrary, where you actually draw that line. And if you draw the line anywhere sensible, you're looking at a series of activities that have gone on under the heading of exploration that may cost in the millions of dollars, so that a company then applying to license a mine has a multi-million-dollar investment in the site. And having that multi-million-dollar investment in the site, if your government then says, well, we're sorry, but we don't allow uranium mining here, they are then liable, or likely to be liable in court, to have to repay the damages to that company. In fact, there was a mining company that bludgeoned an American county into submission over that, using that very argument that their exploration costs had been substantial. The county tried to make uranium mining illegal and was intimidated out of doing that by a threat of legal action. So it was, I think, an accomplishment that we got the inquiry to look at exploration. And in fact, as part of the process of looking at exploration, we were able to, the commission was able to subpoena information that the exploration companies had, which they traditionally regard as extremely secret. It's just out of question to be allowed to look at that information if you walk into the mines department office, for example. That simply doesn't occur. And as a matter of fact, at one point there was a several-day debate. It turns out that one company discovered a particular kind of uranium deposit, which I hope maybe I'll be able to clarify how it is that it occurs. It's called a young uranium deposit. And what it amounted to was uranium that had been transported away from its original point of deposit by water that makes it soluble. We've got some information on this if you're interested in the chemistry, about the details of the chemistry of that. Okanagan water chemistry lends itself to moving uranium. Once it's moved, it no longer exists with its decay products, which is what I want to look at a little bit later on. And that means that its radioactivity and its toxicity is significantly diminished, because the hazards of a uranium deposit, or working around a uranium deposit, have to do as much with, in fact more to do with the breakdown products of the uranium than with the uranium itself. So the water moves this stuff out of the hills where it was deposited naturally, and in some cases, in the Okanagan primarily, when those streams go through anaerobic conditions, as you might get in a peat bog, for example, the uranium stops. It gets filtered out, partly physically by the fibers of the peat, but primarily by the change in pH and by the absence of oxygen, by the reducing conditions of that water. You get a deposit then that's almost straight uranium. It doesn't have any radium associated with it, no radon, none of the decay products. It's a little bit easier to mine it. In fact, there were special techniques proposed for mining it. The main thing that had been discovered that was of interest to everybody at the inquiry was that there was a town that had been built on top of one of these things. Now, the question that was discussed for several days was whether or not, if you can believe this, whether or not that information should be made public, because it is the tradition in the exploration industry that that information is a proprietary secret. They spend money acquiring that information and don't want to give it up. So I think you can see that it was a substantial accomplishment to have gotten every exploration company in the province, and this extended to some in excess of 100 companies that admitted to doing uranium exploration, to provide information about all of the locations where they were doing that.
Question?
Sure.
Did all this come out in the Bates Commission, or was this subsequent to that?
No, this was part of the Bates Commission.
Oh.
This was the initial two
Right.
stages of the Bates Commission. The initial stage was an overview, and what they meant by overview, I think they thought they were going to kick our butts on this. What they meant by overview was uranium geochemistry, and that was a real dense beginning.
Must have woke people up a bit.
Well, it made people decide whether they were going to be awake or asleep during the whole process, I can tell you that.
At least that, yeah.
When was that?
This was in 1979 and
Yeah.
1980. And then the second stage of it was exploration. From there we went on to looking at different types of mining processes, and then to different types of milling processes. And then once the industrial framework was established, then the idea was to go on into environmental effects, health effects, and then there was another accomplishment that we never got to, unfortunately, but the final stage was to look into the matter of jurisdiction and ethics. There's a whole question of the ethics around mining uranium. The argument that the people who are opposed to it were trying to make was that it simply was not in the public interest to mine uranium, that mining uranium was analogous to dealing cocaine or something else that we just don't do here. And that's largely a cultural decision. It's as subjective as anything else, and in some places you do it, in some places you don't, and we wanted to argue that this is one of those places where you don't. And that's an ethical question.
Of course, yeah.
Okay, and to the commissioner's credit, they established and were in the process of finding expert witnesses in ethics to give testimony and to be cross-examined. Now there's another benefit of the inquiry, and that is that all of the people who were there, from government agencies and from the mining companies and also from all of the communities, had an opportunity to cross-examine all of these witnesses, ask any kind of questions you wanted to ask, clarify any kind of information that you were in doubt about, and to try to pin them down to something if you thought you could. I think it was an extremely valuable process. It didn't accomplish the main thing that a lot of people hoped that it would accomplish, but it did accomplish a lot of other things that we never had any reason to hope that we would accomplish. And we have still met all of those people. We all know one another and have dealt with one another and that sort of thing. So there's a lot of value in that, I think.
Jim, did the commission not deal with ethics in the end?
What happened was that at the end of February 1980, the government decided to call a 7-year moratorium on all uranium exploration and development and to cancel the inquiry.
Was that interpreted as an attempt to diffuse that last issue, not have it heard?
I think it was, well, you see, they really hadn't heard all of the evidence on environment or on health, and hadn't heard any of the evidence on ethics or jurisdiction. So I think that was part of it. I think they also understood, it was certainly clear to us, that in addition to the communities that were there were some other communities and other companies that weren't there, where there had been activity going on toward the end of the previous summer. And we knew of several communities where they were talking about doing civil disobedience again. They have to understand what was going on, and this again is to the credit, I think, of the commissioners. all of the proceedings of this inquiry were being televised. So that was like 4 days a week, every other week. That meant that if there was a community that wasn't there, but that was setting up a blockade across the road, or was having people arrested in it, something about that was going to be on TV. And it was going to be on TV yesterday and today and tomorrow and the next day, right on into the exploration season. See, it was at the end of February. End of February, snow's going to go. You get into March, you're going to have those guys going back into the hills and setting up equipment and stuff. It's the beginning, beginning of the season. I think what they wanted to do was to say, we're not, we don't want to deal with that. That's more than we bid off here. And we want to give a clear signal to the exploration industry that they shouldn't set up any equipment because they're going to run into trouble. And I think they got a go-ahead on that from the actual mining industry itself, because at that time there were no companies in the province with mines in the province that also had serious uranium sites. That's not true now. That's changed since then, but that was true then.
Can you tell us, I don't know if this is the right time to bring it up, but can you tell us the status of, I understand there's an injunction against the BC government to ban the lift on the 7-year moratorium, lifting of the moratorium on uranium mining in BC, pending the completion of the Gates Commission inquiry. Can you tell us the status of that?
I can't tell you anything about that, and that is odd to me because I am a member of that committee. So, there are things that like I say, I don't know of any exploration activity that has gone on in this province this last summer. Let me just finish one thing. The 7-year moratorium came off the end of this February, and there was some debate about whether that should happen or not, and it was resolved by simply allowing the moratorium to expire. So there is no moratorium now, and now, as far as I know, there isn't any exploration activity that has gone on. Okay, there is a proposed court action to enjoin the government against allowing any exploration until after the commission has completed its work. But I don't know. At the Hanford conference, there were people there who were getting people to help with that.
Yeah.
I signed my name on the list, and I haven't heard anything.
Okay.
So I don't know what that means.
I see.
If anybody does know what that means, or if anybody has heard of any exploration activity going on, I'd certainly like to know about it. And I think there will be a meeting the 28th, 29th, and 30th of this month in Rock Creek of groups that are involved in the uranium mining and the moratorium issue, and I'm sure they would be interested in it too, because as far as, it's not like I've had my head in the sand or my phone disconnected. I've been talking to people who've been involved with the issue, and these things just haven't come up. I think there are possibly good reasons why they haven't. Uranium is not a hot commodity right now.
If you just want some information and want your name on the newsletter list, can you sign up somewhere tonight?
Sure. Yeah. Yeah.
I was a little curious about something you said just about 5 minutes ago. You said that at the end of the uranium inquiries, that none of companies had any active, or was engaged in any active uranium mining at that time. But then subsequent, you said this is not the case. How come what's happening here? What's the difference between?
Okay, I think maybe what I said I didn't say clearly. In BC, there are two different organizations. There's one that's the BC Yukon Chamber of Mines, and they are an organization that exploration geologists and exploration companies relate to. They have a museum here in Nelson.
Yeah, I've been
Okay,
to Vancouver a couple of times.
Right, they have one in Vancouver. That's the exploration organization. They are not mining companies. Some of them are companies that also have mining interests, but exploration is what that organization is about. Then there's the BC Mining Association. The BC Mining Association is an association of companies with active mines in the province. Now, when the government decided that the shit was going to hit the fan and they wanted to see if they could put a moratorium on, I believe that they went around and tried to see who would object. and they almost certainly got objections from the BC Yukon Chamber of Mines. But from the BC Mining Association, I believe that they didn't, that they got tentative support for that because none of the member companies of the BC Mining Association had really serious uranium mining claims at that time. The really serious uranium mining claims are, the most serious two are at the Blizzard property near Beaverdale, and that's owned primarily by Norsen. Ontario Hydro owns some shares in it, and the share structure of that has diversified since that time. But those are the main players in that one, and they are not members of the Mining Association. And the second one that was a serious one is near Clearwater, BC, north of Kamloops, and that was then owned by Consolidated Rexpar, which is a wholly owned subsidiary of Denison Mines. Now, what I meant when I said that situation has changed now, you see, Denison Mines was not a member of the Mining Association at the time. But since then, Denison Mines has come in and developed a major coal site in the northeast part of the province. So that they are now, apart from their interests in uranium mining, they are members of the Mining Association. And they are big shots. They are big guys. So I don't think that if the government wanted to put a moratorium on now, I don't think they'd get the kind of support from them, even very qualified support from the Mining Association that I suspect they probably got at that time, because the Mining Association knew that they were in trouble. It was just it didn't seem like it at the time, but in retrospect, it was a bit of a field day for us.
Yeah, I thought that was kind of strange, because if there's been a moratorium in effect, how come they've discovered more uranium locations or sites through active exploration?
Well, I think there's a reasonable answer to that. Although I think there's probably a certain amount of paranoia that's justified there. I think we knew at the time, and the government insisted that it was true also, and used this as a reason for not putting a moratorium on, that it was unenforceable. Not only is it unenforceable, but the reason that it's unenforceable is important to understand. When a geologist or even a company goes out to explore a site, they don't, in the initial stages, know entirely what it is that they're looking for. They may take core samples out and then examine those core samples for a number of different things. So they can't say, yeah, we're going to go out and look for uranium, but if we find gold, we'll forget it because we're not interested in that. They're interested in mining whatever they're going to find.
It looks good.
Yeah. So enforcing a moratorium would involve mind reading or something, or reading the future, something like that, and it really wasn't enforceable. But I think what the moratorium did accomplish was that it seems to have prevented the companies with existing and serious claims from developing those claims to any extent.
What then was the rationale behind the argument we heard from the mining company representatives just before the moratorium was lifted, that they must have it lifted in order that they can do any mining at all? The exploration would be crippled if they didn't have the uranium moratorium.
Okay. We gradually
trying to understand other people.
I understand the argument, and there's an answer to that, unfortunately, and it's a rational answer to that, and it leads us to having to deal, if we're going to deal with the uranium mining issue, and it leads us to having to deal with certain really pretty technical kinds of questions. I think the rationale there is that British Columbia is a highly mineralized region of the Earth's crust. And in a highly mineralized region that's granitic as well, you're going to have a certain amount of uranium and a certain amount of radioactivity that is in excess of what you find in other places that are less mineralized. So that it's a little bit of an oversimplification, but not much, to say that no matter what you mine, you're going to be taking some uranium out of the ground. You may not be extracting it as a commercial item, but it's there anyway. It's coming out of the ground. You may find, there were studies done here, unfortunately they weren't found, but it's still a possibility in other areas, or a possibility here, that you'll find gravel pits or sand pits that are radioactive. And that's one of the ways that radon gets into houses, is that they're building materials that give off radon gas because they come from moderately mineralized, uranium mineral deposits. They may not be commercial deposits, but it's still there.
Excuse me, Jim, would you like a cup of coffee?
Sure.
Do you want anything in it?
No. Now that, you see, that is one of the questions that really is where the issue stands right now. That question, and the question that I want to look at. See, it's a whole question that reality confronts us with something that's a good deal more complex than language. It's more complex than any kind of slogans that we're going to be able to come up with and marry ourselves to and charge down the street with. It's difficult. The issue has gotten to a point where it's difficult to politicize it because it's complex, and we're involved in that technical complexity. Maybe it's a bit of an indulgence that we're able to consider that technical complexity because the market is so poor right now. So that none of the companies that have even the serious claims really want to do anything about them at this point. And even if they did want to do something about them, I'm sure that the kind of opposition that they encountered before is something that would give them pause.
Well, if it's soft now, why was it not soft in the 70s? I don't understand.
It was softening in the 70s. It was getting worse, but it hasn't hit the bottom yet. I think it's something like 16 1/4 a pound now, and every time I look, close to 50, that was a reasonable spot price, and that's what I'm comparing it to now as a spot price. I was talking, just to bring a whole different issue into it, but I was talking to a guy who was acquainted with Bates, and he's the head right now of this committee. Special waste is the BC euphemism for hazardous waste. And BC is at a very advanced stage of developing a hazardous waste management system. This guy is a medical doctor, head of the Cancer Control Agency as well, and is chairman of this Special Waste Advisory Committee. I mentioned the Bates Commission to him and my concern with radioactive waste. And one of the things that he said was, well, I don't worry about uranium anymore. I don't think there'll be another fission reactor ever built. If you don't know anything about superconductors, find out about superconductors because fusion is going to be the next thing and it's right on the horizon. Now, I have always been inclined to sort of poo-poo stuff about fusion, but there was something about, I mean, the guy knows his way around some technical issues anyway, and he did seem very, very confident for somebody who works in a field where you're dealing with statistics and mushy sorts of things all the time. So it inclined me to wonder if maybe that was true. My impression, I just got back from a trip in the U.S. and I spent some time in Chattanooga, Tennessee, where the Tennessee Valley Authority has its head offices. And one of the things that was going on there, and it seems to me it's something that the nuclear industry has been preparing, is that nuclear power is trying to get it together for a comeback. TVA is certainly trying to get it together for a comeback. They've got 3 reactors that are totally built and shut down, and they have a guy who seem to be a lot of these guys around. He's a former Navy admiral who is now in charge of their nuclear program, and his commitment is to get those 3 reactors back online by the end of the year. And the last article that I saw was an article about him trying to decide whether his family or the nuclear program was more important. That's the truth. So I don't know how secure we are in kind of relying on market conditions at this point.
Well, the last figures I heard about fusion research, and this is as far as in the U.S. context, as far as the United States government was concerned, that I don't know if it's their current fiscal appropriations for fusion research or not, or whether it's some little time ago, but it was about $50 million giving out for federal money for various national down there fusion research programs. I don't know how much might be coming from the private sector, but that to me doesn't sound like very much money.
That's chicken
But the
feed. That
federal
wouldn't
government
even,
is
that
putting
wouldn't
up
even
with such
build
a
a.
colossal project.
Yeah.
And the point that I'm trying to raise here is that if that looks like it's going to be the case that's coming on the horizon, I think we'd have heard a lot more about it than one or two little bits and pieces of information on the news that come out scattered recently.
Mhm.
One thing that may be tied into it though would be military expenditure that's related to fusion. It might not be flagged as fusion research. Like I know
Yeah.
the Livermore lab gets a lot of military funds and they're doing fusion research with lasers. Now, I don't know, but it's possible that in some budget someplace it doesn't appear
Yeah.
as fusion research even in
I see.
actuality.
It's buried somewhere in the books.
Yeah.
Maybe. I
Yeah.
don't.
That's certainly a
I know that
possibility.
the Livermore lab is really working hard on it, and
Yeah.
there's a private utility that's trying to get some
So it's
approach.
Sandy in Albuquerque.
When I was in Saskatchewan, one of the things that the authorities there were talking about is speculation about bringing China nuclear. And this was their big hope for facing the economic doldrums.
Mhm.
Has there been any recent news about whether China is really serious about this?
There was
Because
a-
you can just imagine,
Yeah.
how do you give power for 1 billion people who want to industrialize?
There was an item in the paper, I guess 3 or 4 weeks ago, but shortly before I left, to the effect that China was going to take spent fuel from West Germany in exchange for some reactor technology. I believe it was reactor technology. But that was, these were short articles in Vancouver papers where they don't have a lot of stake in reporting a lot of detail. And it was subsequently shot down, I believe, by the German government. My impression is that the original deal was sort of being negotiated between the Chinese government and some large private interest in West Germany with spent fuel to deal with.
The other thing, I don't want to deflect you too much from the main thrust. The other speculation here is that one might find a tendency in the United States to develop sub-nuclear weapons uses of uranium in line with the tendency, or actually you might call it the fear of the Pentagon, that if the nuclear weapons delivery systems are brought under control, that they will have to have some substitute, and there is a strong tendency to move toward conventional arms facing up to that issue. And a whole new generation of conventional arms is being invented, which uses uranium bullets. Now the question of what proportion is involved is something I don't have an empirical grasp on, but you have to look at the 235, 238 processing, and that involves the operation of the rest of the system, so that you have left over enough uranium-238 to make these nasty little bullets out of by the millions. They're looking at tons of them.
Yeah.
So just knowing the way military people think, I wouldn't be surprised at what somebody would come up with a good ideological reason to increase uranium production, because that's the weapons of the future.
There'd be a kind of political advantage to doing that too, because there's a perceived fire break that has to do with nuclear war, that there's a psychological resistance, reluctance to commit nuclear war. And it seems to me that the weapons makers have approached that by trying to blur that line somehow.
Yeah.
And if you had uranium bullets and some kind of nuclear hand grenade and that sort of stuff that you could come at. See, this is exactly, and this brings me right back to where we were. This is exactly the kind of thing that we're dealing with in the uranium issue. Only it's geological complexity that we're confronted with, rather than a manufactured complexity that makes it a difficult issue to formulate policy about. And if the military is able to put together an arsenal that is so radioactive, even if it doesn't involve fission, that it's difficult to discuss what is nuclear and what's not nuclear, then we've got a new layer of problem. Or one of these hotshot Saskatchewan mines that's so rich in uranium that you don't even think about even dirt being there. It's all uranium, and you worry about the uranium. But in reality, most uranium mines have something else going on with them. The South African mining industry has developed a major byproduct industry in uranium as a byproduct of their gold mines. Their gold mines are mainly gold mines, but they are major uranium producers, and what they produce is produced on secondary circuits in their mills for extracting uranium. It's a very resilient industry, by the way, because if the uranium prices go down, you're still mining gold, and you still go on doing that. You don't stop. Whereas the Canadian government has had a very difficult time putting together a resilient uranium mining industry because the prices fluctuate so wildly, and because the United States has a tendency to barricade itself off when its own producers seem to be jeopardized as they are now. The main buyers, I think, right now of uranium are military buyers.
Can I just add one more thing before
Sure.
we go on that was brought up by Jack Ross, and that is many of the U.S. weapons labs right now are involved in the research. I don't know if it's at the design stage yet, but at least it's at the research of what are now called third-generation nuclear weapons. And these are in the low yield range to develop weapons or bombs that will, when they explode, will highly focus their energy as a kind of a focused beam of X-rays or neutrons. And there's a very good article that covers this in the, I think it's in the March 1987 Scientific American. So if anybody is interested in finding out about that aspect of what's going to be coming down the line as far as new nuclear weapons are concerned, that's a good source to check up on.
That is one of the major
So there
things
might
in
be-
the Star Wars.
That might act as a goad towards an increase possibly in more uranium extraction and possibly exploration. It might affect here as well.
Yeah. Okay, what we're confronted with right now is not serious, in BC, is not serious proposals to mine some uranium deposit that is only or even primarily uranium. We have situations where in the Atlin area, for example, there is a deposit that when we were looking at uranium mining and when uranium was trendy, they called it a uranium deposit. As soon as it looked like that might be an embarrassment to be looking at a uranium deposit, it was a molybdenum deposit. It hasn't been mined, as far as I know, as either one, because the price has not been very stable for molybdenum either. So we've kind of avoided the question on that one. But there is another deposit which Cominco apparently holds, and it is, according to them, the world's richest deposit of niobium, and it also has substantial quantity of uranium associated with it. So there's that kind of deposit where you have several types of mineral values, commercial values, associated with one another. And if you are gonna get one, you are gonna have to deal with both. And so what do? That is one question, one type. A second type of problem is a type of problem that turned out to exist in the Slocan Valley between Silverton and New Denver. There were 2 silver mines up there that I believe it was the Department of Mines, went into with radon detectors and found that they had high levels of radon and radon daughters in the mine atmospheres. They did not have any uranium mineralization that they were dealing with. Their ore didn't have uranium in it. The situation was that there was groundwater coming into the mine that ran through some other deposit of uranium somewhere, maybe not a commercial deposit, but it was enough to leach the radon out, transport it into those mines, and then contaminate the atmosphere. So that you've got mines with a health problem associated with a uranium-related problem, but no uranium mineralization at all. So just the fact that the mine is not taking any uranium out of the ground doesn't mean that that problem may not exist in the mine as an occupational health and possibly even an environmental health problem, depending on where you are in relation to all of it.
And radon gas is the culprit?
Radon gas is the culprit. Radon gas is, and then the radon gas is the next thing, and that's really what I want to talk about. There was a study done in 1978 in the Castlegar Trail area of homes, mainly basements, to discover whether or not there were high levels of radon and radon daughters. And I'll explain what I mean by radon daughters in a minute. Radon daughters are actually the culprits. Radon is the mobile member of the bunch, and it shortly turns into the radon daughters, and the radon daughters, the breakdown products of radon, are what will get you in your lungs, and that is the principal occupational hazard among uranium miners. Radon has turned out in the United States in offices and in homes to be so widespread that the health service there says that it is the second largest cause of lung cancer in the country after cigarette smoking. Castlegar turned out to be the worst non-uranium mining community in Canada. Uranium mining communities have a particular problem because they have houses that have been built on top of tailings, houses that have had tailings incorporated into the building materials, and houses that are built on natural outcrops of uranium-bearing rock in the basement, where the basement isn't finished. You know, you've got a cement floor for part of it, then you've got a rock outcrop in another part of it, and you probably know basements around here that are like that, and those are potential problems. Then there are also problems where the soil is just, this seems to be the problem in Castlegar. The soil is a very granular kind of soil. It's a sandy, gravelly kind of soil. And in a situation like that, when the radon occurs, there is a maximum of surface area compared to the volume of the material that you're dealing with. If it were solid rock and an atom of radium turned into radon, then the half-life of radon is a little over between 3.5 and 4 days. At the end of 4 days, it turns into polonium. Polonium is a solid, so radon is the only gas. If it's in solid rock, then it just goes through that transition and nothing happens. But if it's in sandy, gravelly material, and it goes through that transition, and that atom is on or near the surface of the particle where it exists, it may escape into the airspace, or if it's in a water-saturated area, it may dissolve into the water. And at that point, either way, be moved away from there and into the existing atmosphere or into wherever the water is carried. And in that way, it can get into houses. Either because the houses are built inside a type of sandy, gravelly soil that has a high radium content, or because the water comes from a well that goes through some of that kind of material, and water has an almost unlimited capacity to dissolve radon. Radon is a noble gas. It's an inert gas. It doesn't combine with anything chemically, and it has an almost unlimited capacity to dissolve in water. If that's the case, and it comes into the house, when it goes through a shower head or a dishwashing machine, clothes washing machine, anything that agitates the water or heats the water or both, then the gas degasses from the water and gets into the atmosphere. Then it goes. Pardon?
Or aerates it, whatever.
Yeah. Aerating it is how, if you're measuring the radon content in water, that's what you do. You take a water sample and then you bubble air through it and catch the air that comes out and measure the radon that's in the air that you've caught. And the bubbling of the water through the air will take it out. That's also a potential way of, if you have that problem in your house, you can install something that splashes the water, and that would help release the radon before it came into the house.
So it's possible to detect it if it's in your house?
It is possible to detect it. As a matter of fact, that's what this study is about. There was a study that was done that I mentioned in 1978 that found that Castlegar was, I would say, the worst non-uranium mining community in Canada. The tests that were done in order to go further with this, I have to get into a little bit of the technicalities of measuring it. I guess I'd like to have some sense of whether you feel that this is relevant material to go into, or whether you don't want to get excessively technical. This is miles away from the weapons industry, and there is no civil disobedience that you will do to get anything positive to happen in terms of radon reduction in your house. You will probably have to pay for the measurements, you will probably have to pay for the radon mitigation systems, and you will have to deal with the whole thing. That's the way it is. And the way I see it, how we deal with this problem is how it's going to be dealt with in terms of what the community's radon tolerance is when it comes to setting any kind of standards for if it's uranium mining or whatever else it might be. This is what brings it home. See, we don't have uranium mining here, and we may not ever have it, but we do have radon in our homes. If we say, oh, well, hell with it, I don't mind a little radon in my home, then then the argument comes back, you don't mind a little radon in your home, how about a mine down the road? Why not? Your home will get a lot less in it from that mine down the road. I think there are arguments against this, by the way, but that is, as long as all you're looking at is a radon level and the hazard from that, then that is a valid argument. I think the main reason that people oppose uranium mining is that they want to vote against something that's used to manufacture nuclear weapons. They want to cast their lives against the Holocaust. And that's a whole different issue.
Stern assured us that it's not just the bomb, it's very insidious because it's made to your everyday phone. But I'd kind of like to get into this. You can explain this in this book.
It's also a fact that you simply can't get away from it. I mean, I have a little Geiger counter that I bring every now and then. And it beeps all the time. There's alpha radiation, gamma radiation, beta radiation. It's all around us. Even if we turn the lights out and just, we're living an absolutely natural life, it's coming from the rocks. And it's coming from the rocks more here than in some other places because the rocks are granitic, and granitic rocks have a relatively high level of background radiation associated with them.
Are these kind of instruments available on the market? I won't say readily available, but are they available on the market?
They are available,
price,
that's a really complex question. We looked at that in some detail, and I was really interested to hear you say that
Actually,
you were.
I was working on radon in
Is that right?
Florida and Waters,
Where?
in Ottawa.
In Iowa.
Ottawa.
Ottawa, really?
Yeah.
Huh.
I had a research project, and I was just kind of key on the bottom of the scale, but it was, I just couldn't handle it because they were working with radioisotopes in the glove box, and I don't know, the whole thing is the gas comes out, and they always do the Dalgaard experiments, and I just couldn't handle it. Yeah. But it's awfully interesting because when I was getting into it more and more and doing all this research of while I was doing the analytical parts of what kind of mathematics I could use and reading all this research article, I never even thought about, being into the everyday home. And it just kind of opened my eyes to, how much that I never, but to me it's almost much more, because there's so much more even before you even get it into a bomb, there's so much gone wrong in the first place before you get there. Not supported.
Well, measurement.
Is there any use for uranium in all besides nuclear energy?
It has been used as a glaze for pottery. It makes a kind of yellowy
It's a
glaze.
beautiful glaze.
It's not that
Fine.
big. And it's not like you can't produce it with something else. But it has been used as a glaze for pottery.
Used to be able to get
And does it give off
Canada,
radon gas?
Well, let's do a little, could you help me put some stuff on the board?
Sure. Jim, by the way, I've got the provincial map that shows the uranium in the water and in the sediments. If that would be useful, maybe you can stick it up on the wall somewhere.
Okay.
Just for people to look at.
Yeah, bring it in, I'd like to see
When you
that.
guys are doing that, if people want coffee, I'm sorry I can't offer juices. Couldn't get in.
Okay, what I want to try to do is to convey to you an intuitive sense of something that is a very dynamic, natural situation. And I may resort to a little bit of math to try to clarify it, but it's not really the math that I'm trying to convey, or even the specific details of these numbers, so much as a set of relationships. There are basically three natural decay series that occur in nature. One of them is associated with an isotope of thorium. One of them is associated with uranium-235, which is the fissionable isotope of uranium and is the one that the weapons manufacturers and the nuclear power industry are after, but it is far and away the least common of the isotopes of uranium. And the most common one, and the one that we're concerned about as far as health and environmental impacts are concerned, is the uranium-238 decay series. All of these elements in this list in the left-hand column comprise the uranium-238 decay series. And what that means is this. When you have, I'm going to do a couple of these in detail. Can I take this thing down and put it to sleep?
Turn the-
No, I'd rather not turn off the fan.
Okay.
What for a second?
Maybe if you just flipped it all over to the front.
Yeah.
Let's get rid of that.
When you have a uranium deposit in nature, you have all of these together. And you have them, in all probability, in a fairly specific kind of relationship to one another in terms of quantities. The uranium atom itself consists of a large nucleus with a bunch of electrons going around it. The nucleus has 92 protons in it, and then whatever the difference between 238 and 92 is, I think it's 146, is that right? 146 neutrons in the nucleus. And then around it, you have a balancing number of electrons going around it, 92 electrons. When uranium, you see here that the type, okay, what we have in this column is the half-life. And what the half-life means is that at the end of this period of time, a given amount of uranium will have decayed. It will have given off its radioactive particle and turned into something else. So if you have a ton of uranium, this is 4.5 billion years. So that's a long time. And the idea to get there is that when you have a long half-life, you have a substance that's breaking down, but breaking down very slowly, so that it's not extremely radioactive. On the other hand, if you go down here and you find one like polonium-214, polonium-214 has a half-life of 2.7 times 10 to the minus 6 minutes. Very, very short, like a millionth of a minute, roughly. And all of the isotopes of polonium are relatively short-lived. This one is a fairly long one, but they're relatively short-lived, so that if you have a pure sample of polonium, not plutonium, but polonium, then it is decaying so rapidly that it tends to be actually physically hot. It's falling apart that fast. Whereas uranium, you wouldn't notice it. Uranium is breaking down very, very slowly. And what it does is that it gives off an alpha particle. There are three basic types of radiation that we're going to deal with that are ionizing radiation. People in the nuclear industry will tell you that sunlight is full of radiation, and it is. But visible light is not ionizing radiation. The radiation in this column is radiation that will strip the electrons off of other atoms. so that it tends to break matter apart. And it also tends to be a symptom of matter that is unstable. All of these atoms are unstable. Alpha particles consist of 2 protons and 2 neutrons, and they're positively charged and very heavy. And an alpha particle will be stopped by a piece of paper or by your skin, but it lays down a very dense track of ionization, so that if you inhale an alpha particle or if you eat an alpha particle, then where it lays down its ionization is not in the epidermis layer of your skin or in your clothing, it's in live sensitive tissue. And when it hits live sensitive tissue, the most likely thing that it will do is to kill a cell. A cell that's been hit twice in the nucleus by an alpha particle has a 50% chance of dying from those 2 hits. But if it doesn't die, there's a good chance that it will be maimed in some way that will result in cancer. And the alpha particle radiation is the kind of radiation that we're concerned about with radon gas and with uranium mining. And in fact, it's also the kind of radiation that we're concerned about with the plutonium that is manufactured in the N reactor at the Hanford site. They're all alpha emitters. And for years they were ignored because of gamma radiation. That's this one. Gamma radiation is the most penetrating one. Gamma radiation seems to need something like 6 feet of concrete or lead, lots of concrete or lead in order to stop it, probably less lead than concrete. So it's extremely penetrating, but it does not lay down a very thick track of ionization, so that it might go through you, but unless you walked into a very hot field of gamma radiation, it would be less likely to do damage, although it could do damage to you from the outside because it could go right through. Beta radiation is a kind of radiation that is involved in television sets, for example. Is one type that's involved in television sets. Beta radiation is basically an electron. And electrons are wibbly little things. They are almost light. They have practically no mass at all. They have approximately 1/2000th of the mass of a neutron or a proton. And that means that that in a natural setting, when they're not accelerated artificially, they follow a kind of moth-like or corkscrew kind of pattern. They're not as penetrating as gamma rays, but they are more penetrating than alpha particles. And there is a particular kind of cataracts that's associated with looking at television screens for too long from too close. There are also other health effects, and that's a really complex and very unsettled question at this point. My personal opinion is that it may be associated with radio wave type radiation rather than ionizing radiation, what those health effects are. It's not really clear either that all of the health effects that are suffered by operators of video display terminals are associated with the video display terminals. It's becoming clear through studying radon and other indoor environments that there are a lot of environmental hazards inside of office buildings that nobody ever expected before. In fact, working in an office is traditionally regarded as probably the safest kind of occupation you can have. But there is stuff that builds up inside of poorly ventilated office buildings that is analogous to photochemical smog because of the ultraviolet from these lights and the chemicals from photocopying machines and the radon in the building materials and a host of other stuff. No carbon required carbon papers put little fragments of plastic into the air, and people who have to deal with hundreds of those a day suffer from irritation to their nasal passages. There are also biological contaminants that happen in buildings that are a problem. Okay, so back to here. We have a uranium atom, 92 protons in the nucleus, 92 electrons going around the outside, and then the rest of the nucleus is filled up with neutrons. It's going to give off an alpha particle. And that is the main thing that we're concerned about. We're concerned about radiation, but it's going to leave behind it something with an atomic number of 90. We look over here, and that's thorium. It's got an atomic weight of 234. The alpha particle is 2 and 4. Okay, so that it all balances. You've got 92 minus the 2 is 90, and the 238 minus the 4 is 234. So that is the basic radioactive event. This is what's left, but what's left is also still an unstable nucleus. And since it's an unstable nucleus, it's still radioactive. And so we're still concerned about it. It has a different bunch of electrons, a different electron structure around it, so thorium is chemically different. Thorium, by the way, is used in mantles for gas lamps. You can see here that the half-life is quite a bit shorter, so that you have atoms turning very slowly now from uranium-238 into thorium-234. But as soon as they become thorium-234, they turn pretty quickly into the next one, which is protactinium-234, and then that one is only a little over a minute long, and it turns almost instantly into the next one from there. What happens is that over a period of hundreds of thousands of years, if this whole situation is in one place, and water doesn't come along and sweep some of it away, or if it doesn't crack up and get carried away by a glacier or something, that stays in one spot for long enough, you build up an equilibrium where each one is turning into the one below it as quickly as the one above it is turning into itself. Now, the mathematical way of saying that, and I'll give you this because I find it sort of explains it easier for me than I can put it into words, is that you have a decay constant and the number of atoms. The N0 is the number of atoms, the lambda 0 is the decay constant, and N0 lambda 0 is the expression, let's say, for uranium. And equilibrium occurs when N0 lambda 0 is equal to, I'm going to erase that one, to N1 lambda 1, and that is equal and so on to N lambda n. In this case, I think it would be 14. So that the multiplication of the number of atoms in the sample times the decay constant, which is inversely proportional to the half-life, gives you an expression that is equal all the way down the line. That number of atoms comes into a calculation when you're trying to understand the units that this stuff is measured in. And particularly for those of you who live in this area and who may have houses that you're concerned about and will probably be involved in that aspect of the issue, I think it's useful to understand what working levels are. There's another unit that is named after the Curies. It's a Curie, and the common form of it is the picocurie. And a picocurie is equal to 222 disintegrations. I think it's per minute. Let me check that. Per minute. Yeah. Per minute. And essentially the way that this works is that when we have equilibrium, then we would have a quantity of uranium that will give off 222 disintegrations per minute, and a corresponding quantity, not the same quantity, it might be a ton of uranium, and it would only be a few ounces of thorium-234 that will also give off 222 disintegrations per minute, and another proportional quantity of protactinium that will give off 222 disintegrations per minute, and so on. When the whole system is in equilibrium, everything, each different element is giving off the same number of disintegrations per minute, disintegrating into the next thing as quickly as the previous thing is. So it's like a series of pools in a waterfall, with one pouring into the next one, pouring into the next one, pouring into the next one. Each one of these different elements has different chemical properties and different physical properties. Now, the uraniums are very similar, but they have different atomic weights, and so they could theoretically be separated, and they have different half-lives. You have several different thoriums here. And I don't want to get too concerned about it. The one that we're concerned about, or the ones, are here, radon. That's the radon that we're concerned about. And then those three. And you notice, I'm sorry, those four. You notice that those four are very short-lived. Their half-lives are in the range of a minute or less. So that, now radium, which is the one that turns into, it's the parent of radon, that turns into radon, has a very long half-life, relatively long half-life, 1,620 years. So it relatively slowly turns into radon. Once it turns into radon, radon is relatively quick to decay into something else, and as soon as it decays into polonium, then you go through a very rapid fire decay in a matter of minutes. Okay? So that's what I want you to picture in your basement. Radon does not combine with anything. It's chemically inert. It will combine with things, but only under extraordinary physical circumstances. It doesn't ordinarily combine chemically with anything. If you inhale a bunch of radon, some of it will dissolve in your blood, and most of it, that's like 10 to 20% of it, and the rest of it you will just exhale, and you'll have no problem from that. So it's not radon really that is the health problem. Radon is a problem because right here in the middle of this whole series, it's a gas. Everything else in this is a solid. Some of them are metals. But this is a gas. And if you have that situation that I described earlier, where you've got, instead of a big block of 1,000 tons of rock and all of this stuff is going on inside it, and nothing but what's on the relatively small surface of that rock is going to escape. If you've got sand and gravel and lots of surface area and lots of atoms that are eventually going to turn into radium that are on the surface of those little grains of sand, then when it turns into radon, it will escape into the air. During periods of low atmospheric pressure, the stuff that's in the soil space between those sandy, gravelly particles will be relatively sucked out. The emanation rate of radon from the soil will naturally increase during periods of low pressure. And it'll come into your house.